Math 1, Practice 3.1.4, Solving Exponential Equations. Now, exponential equations are a lot more difficult to solve, and it takes a lot of skill and practice here to do these. It's not a simple step-by-step like the other ones, okay? And there's some rules, some properties that will help us. So, first thing, anything to the 0 power equals 1, okay? Just a fact of life, okay? Also, anything to a negative power is the same as 1 over that same thing. Okay? So, the trick here is to get the bases the same. In powers, okay, something like that. The number being raised to a power is the base, then you have the exponent, and then you have what it's equal to. Okay? So, if we look at the way to solve exponential equations, the trick is you're taking a number and you have to say, okay, C can be what? It's that same base to what power? Okay, and then you look to match up the powers. That's really the only way to solve exponentials. So if I look at this first one, 8 equals 2 to the x. I want to say, is 8 2 times 2 times 2 times 2 times 2? Is it something 2 to the something power? And it actually ends up being 3 2's. So if I go 2 times 2, that's 4, times 2, that's 8. So 8 is really 2 to the third. So then, now that I have the same base, I can set the powers equal, so 3 equals x. And that's my answer. So this one's really kind of a tricky one. So, looking at number 2, we have 3 to the x equals 81. Well, 81, is it 3 to the some power? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the x, actually 81 equals 3 to the fourth, so x equals 4. Okay, now number 3, really, that's like 25 to the negative 1 equals 5 to the x. Well, 25 is just 5 times 5, right? So it's really 5 to the negative 2 equals 5 to the x, so negative 2 equals x. There's our answer. Okay, and number 4, 4 to the x equals, well, 64 is 4 times 4 is 16, times 4 is 64. So it's 1 over 4 cubed, which, if I take it out of its fraction, it's 4 to the negative 3. So we get x equals negative 3. Okay, number 5, we have 1/2 to the x. So 4 is like 2 squared equals 1/2 to the x. Okay, then that's like 2 to the negative x. So 2 would equal negative x, which means negative 2 equals x. Okay, number 6, it's kind of the same idea. 216 is 6 to the 4th. 6 times 6 is 36, times 6 is actually, nope, it's to the 3rd. So you have 1 over 6 to the x equals 6 to the 3rd. So if I go and make that 6 to the negative x is equal to 6 to the 3rd, we get negative x equals 3, or x equals negative 3. Okay. Now number 7, 100. Well, 10 times 10 is 100, so 10 squared equals 10 to the x. So 2 equals x. Number 8, 0.5 to the x equals 0.0625. Oh, that's a tough one. That's where a calculator would help, and you just go 0.5 times 0.5, which I believe is 0.25, times 0.5, and we get 0.125, times 0.55, 5, 2, 10, 12. There we go. So it's 1, 2, 3, 4. So it'd be 0.5 to the fourth equals 0.5 to the x, so 4 equals x. Now on 9 and 10, sometimes you just have to do a little extra work to get there. So we'd subtract 7 first. So 2, that would become 216 equals 6 to the x. Well, 216 we already discovered was 6 to the third, so 6 to the x, so x equals 3. And the last one, we would add 3, and we'd get 7 equals 2401 to the x. Whoa, this is a weird one. So, I think what they're trying to make us do is go backwards on this one. So we'd have to go 7 times 7 is 49, times 7 is 63, 28, so 343, times 7 is 1, 2, 28, 30, 21, okay, 2401. So it'd be 7 equals, that would be 2401 to the, 1 over 7. That's a weird one. That would be to the first. So, this one's weird. I want to say x should equal 1 to the 7th. Or not 1 to the 7th. Because we did a 2, 3, 4. That would be 7 to the 4th. And so 7 equals 7 to the 4th. The only way that would work to take it back to 1 is if this were 1 over 4. If x were 1 over 4. Anyway, those ones don't freak out too much if some of those are way too complex. But that's just the main idea when you're solving with exponentials.